So this is the lab determination of unknown amount of citric acid. I hope this is the lab he wants to be done. Okay. So essentially what we're doing for this lab is we're making different solutions and we're going to try to calculate the concentration of each of the solutions, because as long as they're the same compounds in both, so in this case Kool-Aid and water, if we know one concentration and one volume, then let's say we know another volume but we don't know the concentration of that second one, we can calculate it by using this lovely equation. C1 times V1 equals C2 times V2. So the first concentration 1 multiplied by the first volume is going to equal concentration 2 multiplied by the second volume. So we're able to dilute stuff and calculate it accurately. Okay. Let's see.
It's a little long for the rice, Willa. Hold on.
Oh, not 20 minutes for the rice. 20 minutes for my game.
I'll text Dr. Henry right now. Tell him that Hartnell doesn't have the lab.
20-minute what?
20 minutes for my game.
What game? Don't you have to do your homework?
The game is one.
Oh, Imagine Learning? All right.
Yes, I want. And I have to play for 20 minutes. So when I log on, let me real quick flip that like a pancake.
Why don't you just copy all that, paste it into a document, and then you can put it in the chat and we could just copy it. Or put it in.
I could try, but what's gonna probably happen is all those equations are gonna get messed up pretty quickly.
You can put it on a document that we can all edit, and then we can just create a page in Canvas. Copy and pasting is how I got through the whole semester, Cole. So you need to step it up. What do you eat with that? You just dropped it on the floor. Just get another one.
It's nice.
There you go. Oh, that's a lot. Oh, that's a lot. Shouldn't we be like studying for the final or something?
Should, but you also are going to be doing labs. Ugh. Hopefully Dr. Henry just gets back to me. And give me 1 second. Don't want you guys to see my private information.
Yo, how come I'm the only one that still uses the lab glasses, man? They gave us lab glasses and y'all never wear them. Shameful.
Lab safety is overrated.
I'm in the lab safety group, all right?
I didn't get any
Hey.
lab classes.
Lead by example.
Dr. Henry is here.
Throwback to the 90s.
Dr. Henry, glad you can make it. It is currently chaos here.
When you hear that,
It wasn't me, Dr. Henry, not this time.
Oh, really? It must be Edgar then.
It's definitely Edgar.
It was definitely Edgar.
Yes.
Okay, so Hartnell does not have the lab up. Let me fix it quick. Okay, we're making modifications because the other lab required you to have some equipment that you guys don't have. So, doing it by the seat of my pants.
Hey, Dr. Henry, the lab's not showing up on the Klinga either. It shows up in the grade area, but you can't actually see it.
Okay, so let me fix that too.
I could give it a due
Working for me
date,
then.
Dr. Henry. No.
Okay.
What do you
Yeah.
want the due date to be?
Next week,
Next week?
Or
or the 21st. We could do the 21st since everything else is.
For me, it works. I don't know if this is a problem for everybody else, but if you go through gradebook, it won't show. You have to click into it through modules for the West Hill campus, at least.
you know, that's funny. There's a couple things that don't show in the grade book, like the grades.
Okay, that's all right. I'll just start putting
Shots
zeros
fired.
there. Keep it up. Keep it up.
Nate, you got complete.
It just is, it must be a glitch. That's all it is.
Yeah. They're showing up on my end, Nate. I don't know what your problem is.
I don't know either.
11.
Yo, I never had my camera on. This is crazy. I can't stop looking at myself. This is why I keep my camera off.
Are you
You are,
that vain?
I just can't stop looking at myself. It's amazing. I'm made for TV, baby.
if you right click on your own picture, you can hide yourself if that helps.
But then how do I know if I look stupid? I'll just keep the camera off.
Sure.
I mean,
Never look stupid, Nate. That's fine.
it says the guy wearing the lab safety goggles that nobody wears.
Stylish.
Thank you, Mike.
Okay. Let's see.
Thank you. I mean, I can't be in the lab safety group and not lead by example. You know what I'm saying?
Right.
Exactly. Don't want to be a hypocrite.
Part of the long game. This is part of my final group presentation. I'm just gonna do a all of the labs where I'm wearing my goggles spliced together in my final video.
Okay. So let's see. Modules. It should be showing up. Lab 11.
Yes, it's showing up on the Hartnell side.
Although I'm gonna have to change its name. So
Mole.
okay, so that'll get you started. There are going to be modifications because I haven't had a chance to test it out under your circumstances. So I'd like to see how it works. And then we'll make modifications as we go.
I found in many foods, drinks, pharmaceuticals, shampoos, and cosmetics. Citric acid. Today, you are working in the quality control department at a manufacturing plant. Ooh, some role playing. Okay. Working in a powdered drink mix. The quality control department monitors the percent citric acid in samples of the powdered drink mix to verify that the percentage is correct. Okay. If the powder mix contains too much citric acid, the drink mix will be too tart. Too little citric acid.
It's not possible.
Too tart, it's not possible.
Yeah.
Too little citric acid produces a drink that lacks tartness. The tartness of the powder mix is important to consumers buying this product. Before beginning your experiment, make an estimate as to what percent of the drink mix is citric acid. Hint, read the ingredients listed in the sample of the powdered drink mix. Ingredients present in the greatest amount are listed first. All right, so look at the back of the Kool-Aid pack. Step 1. Grape or blue, Radden, help me pick. Grape or blue raspberry lemonade? Let me give you a hint. Whichever one you pick is not the one that you're going to get to drink. Which one? Blue raspberry lemonade? You want me to use that for the science experiment? Use the grape? I agree. Blue raspberry lemonade kind of looks good, huh? But I like grape. But I've had grape a lot of times. I haven't really had blue raspberry. All right, so grape is the science experiment. Citric acid is listed first. That means it must have the highest amount. Okay. It doesn't give me a percentage here. Ingredients present in the greatest amount of this first. What percent of the drink mix is citric acid? I don't know. Do you guys' packages say how much citric acid percentage it is?
No.
I think we're actually going to like do stuff in the lab that's going to test that. I don't know.
Well,
Yeah.
the first step is to
So what percentage do you think it's going to be? Oh, citric acid.
well, it's first, so I'm gonna guess like 50% or more.
Okay.
It's listed first. I don't know. That's just a guess.
Okay.
The tartness, I don't know. It seems like a lot though. 50% citric acid. I'm gonna go 20%. I'm gonna
It's
revert.
the acid base titration that's going to determine the percentage of the citric acid. That's what it says in the lab 12 stuff.
Yeah, but it says first we gotta guess. So we got our guess.
Oh, we have to guess.
The quality Kool-Aid is a product on the commercial market that contains a high abundance of citric acid, C6H8O7, and with approximately 2% ascorbic acid, vitamin C, C6H8O6, in approximately a 100-to-1 ratio. Citric and ascorbic acid will react with sodium bicarbonate. We will be concerned only with the total moles of acid present and will designate the moles as citric acid moles. Please note, it is possible to determine the actual amount of ascorbic acid present by titrating the sample with potassium iodate using a starch indicator. See reference below. All right, what's our steps? The Kool-Aid will be weighed and quantitatively dissolved in the water. We can calculate the concentration in percent mass by the following equation. Percent mass of solution Kool-Aid, percent mass of solution Kool-Aid and water. All right, so let's do the steps first, take our data, and then we'll do all these calculations. C1 times V1 equals C squared, C2 times V2, 2 times V. Okay. Measure out half teaspoon, 2.5 grams of Kool-Aid put in the conical tube. Which one's the conical tube? Is that the one we used for our last experiment?
Yeah, you have two of them. They're round. They're 50.
Ah. With the toothpaste. Can you hand me my scale, Bubba? We're gonna put 2.5 grams in this piece.
I'm over here.
And Nate, do me a favor, refresh your screen.
You need my help.
I have to make some adjustments as we go.
Who?
But that's interesting. If you don't have an exact scale to weigh this, about what would be that 2 grams?
Yours says exactly 2 grams. So if you take a half a teaspoon is about 2.5 grams.
Girl, you ain't got no scale in your kitchen?
I do, but it's far.
Just cooking all.
Did you say it's far?
She's like, can you give me other ways to do it? That might I gotta get up and go get my scale. I hear it.
Brittany, if you refresh the page, it should update the instructions.
Brittany, that's what you got kids for. Watch. Ryden, can you grab me my scale?
No, remember I said I leave him at the Boys and Girls Club so he does not interrupt me while I'm in class.
Ah, see, it works. Those are the fringe benefits of parenthood, you know? I already got her learning how to make coffee and everything. Life skills, life skills.
Yes, child labor.
Hey, it don't ever stop when you get older.
Yeah, I'm not sure if that's life skills, but
You're gonna be working like a dog forever.
It's true.
2.5 grams of Kool-Aid. All right, let's see. Oh my God, on the dot with the first pour. I got those skills from when I was a teenager, you know what I'm saying? Look at that. I could eyeball 2.5 grams still. Yo. All right, here we go. That's done. What's up? What is that? How you get your hands so dirty? Were you beating up kids at school? Just like daddy? Okay. All right, 2.5 grams. What's next? Add bring conical tube up to 50 ml of solution. Okay. I think I know what that
That's
means.
why it's called a minute minder, because it reminds you how long you have to do things.
Yeah, that's why it's a timer. All right, I only got one shot at this. Bring it up to 50 mil. That's all the way full, huh? We supposed to fill it to the top then?
Yep.
Okay.
What's the distilled water or just like faucet water?
That's a good question. Were we supposed to use
No, it's regular water is fine.
Okay.
We said we needed our distilled water.
Oh, you will need your distilled water. So you're gonna use your distilled water for your cabbage.
All right.
Man.
I got the tube.
At your service, kind of.
Your cabbage indicator.
Chocolate cube still smells a little rank from the yeast.
Yeah, mine smells too. Is Nate the teacher now? Shoot. Might as well be. I'm just kidding. I'm just joking. Everyone calm down, okay? The last week of school and stuff. Last couple weeks. Dr. Henry got too busy with the meetings. He's the teacher of meetings.
Believe me, I hate it.
I would hate it too.
Yeah.
All those meetings. That's why I work as a bartender, baby. I just go to work, then I go home.
For the conical tube for the Kool-Aid, are we using the 50 one or the smaller one?
The 50.
Yes, I'll go with it. My stuff now.
Nate, what bar do you work at? I'll come for my 21st birthday.
I work at Lala Grill, Ellie's in Salinas. I bartend there.
Okay.
You can come anytime, Cole. I got you. I'll buy you a round of drinks.
It will be in a couple months because
I think we should all show up there.
I only
Like
bar
a
Sundays.
Chem, hey, we'll have a Chem class reunion.
Whoa, wait a second. Cole's not 21?
nah.
Crazy.
Are you serious?
On Sunday
I'm
nights.
older than Cole. Cole's a Zoomer. The
I'll,
prodigy.
I'll turn 21 end of August. So let's call it August 29th. Make sure you work, Nate.
If it's, I usually work like 2 to 3 bartending shifts a week, but I'm always on Sunday nights and sometimes Saturdays.
If you work that Saturday, that's my birthday. If you work the 29th, I'll just show up then.
I'll offer a request to that shift, okay? And I'm gonna be
Perfect.
at the bar. All right.
Are you 21 yet, Dr. Henry?
No, not yet, you know.
No. We'll have to go for his birthday too then.
That's why Dr. Henry makes his own beer.
Yeah.
You don't need ID.
Look,
Do you have to have an ID to buy ingredients that are in beer?
Nope.
Nope.
Yeah, you can get yeast anywhere.
Like barley and hops and malt and all that stuff, you don't need it?
You can order it online. You can go to the liquor store. Well, some liquor stores actually sell it. But
They're
Yeah.
making moonshine.
If you're in the South, you can buy that stuff everywhere.
yeah,
On Sunday.
you only get it in the South, you know.
Not on Sunday though. You could
Dr.
get-
Henry, real quick,
Hours.
you add the distilled water, right? When it says up to the
No,
50
just regular
milliliter
water.
solution.
right,
Regular
right.
water.
Okay, so that with the Kool-Aid in it, fill it up to the top.
Yep.
All right.
But add the water directly to the conical.
Yeah, and then you put it into an empty water bottle.
And then you add 15 more mils.
Yep. And you want to label that solution 1. That's your main solution. That's the one that you may have to go back to a couple of times.
Right there, right there. Wait, so I'm confused about these steps. All right.
You,
So
you put
I-
the Kool-Aid in.
I measured out Kool-Aid, I put it in the conical tube. I brought the conical tube up to 50 mil of solution. Is that with water?
Yeah.
Yeah.
Okay. Then it says add the empty water bottle. So I pour this whole tube into an empty water bottle.
Yeah.
Yep.
And then it says add 50 milliliters of H2O back to this. So another 50.
No, to your another 50 to your water bottle. So altogether, you're making 100 mils of solution.
But I'm not adding any more Kool-Aid, right?
Nope.
Okay, so it's just this tube plus 50 more mil.
That's right. We're gonna say the other Kool-Aid just in case things don't go right.
I'm gonna drink that Kool-Aid.
Got a dry bubble in the Kool-Aid.
What was that?
Ew, red Kool-Aid. Ew.
Because you put in here, right?
Who buys red Kool-Aid?
Dark orange.
Oh, red Kool-Aid's classic, Nate. Why you
Okay, and
hating?
yeah, and red Kool-Aid is a classic.
You probably
Thank
drink
you.
yellow Gatorade too.
I probably do.
Hey. Don't come at yellow Gatorade.
Yellow
Nate's
Gatorade.
making enemies today.
No way, baby. It's all about those cool colors. Don't you guys know about psychology? That's why Pepsi cans are blue, baby.
What's wrong with red, man?
Refreshing. Blue, purple, these are refreshing colors. Your psychology associates those with cool refreshingness. Red is a hot, aggressive color. On a hot day. after
This is a
exercise.
real science class, not like psychology. So
Oh, now shots have been fired. Oh, shoot. Those are shots fired right there.
Red's colored pomegranates, man. You saying those ain't refreshing?
I don't know. After I work out, I'm not like, man, I could really go for a pomegranate right now.
Sounds like you got bad taste, man.
But I am like, yo, I could go for a blue ice mountain Gatorade. All right. So I got 100 milliliters of water. And I got my Kool-Aid solution. What's next?
Dr.
Mix-
Henry, do you
Yep.
want to convert everything to grams or to milliliters?
You want? Well, you want things in grams and milliliters.
Okay, because for the percent mass, like for, what was the question?
That's going to be mass, right? So that's going to be grams.
Grams. Oh my God, never mind.
So it says calculate the percent mass of the solution now. So it's just 100 milliliters converted to grams.
Yep.
Is that it?
Yep.
Okay.
And so we know water, you know the density of water, right? So you're putting mostly water in the system. Is that correct?
Yeah, it's 100 milliliters of water at 2.5 grams
That's
of
right.
solution.
So if we wanted to calculate the percent mass, right, we could just go percent mass of your Kool-Aid divided by your percent mass of your entire solution, which is primarily just water. So you just assume that the density of water is what?
Hold on, let me convert milliliters to grams real quick. So I got 100.
Water's 1 milliliter to 1 gram, right?
Water is 1 milliliter. The density of water is 1 gram to 1 milliliter, yes.
Okay, so 100 milliliters is just 100 grams.
100 milliliters is just 100 grams. Correct.
Oh, so it's 2.5% of Kool-Aid mixed to, because we put 2.5 grams, right?
That's correct.
That's easy. What's next?
Wait, so for the first part of our problem, it's the 2.5 grams of Kool-Aid over the 100 milliliters of solution as a 100?
It's 2.5. Yeah, so it's 2.5% Kool-Aid, yes.
So our percent yield of Kool-Aid is 2.5, right?
No, your percent
5%?
mass of Kool-Aid is 2.5.
Oh, what does this say to calculate? Let me see.
Yeah, but I'm saying
Calculate the
for our
percent.
calculation, that 2.5 would be over that solution total.
All right, number 6 is 2.5 grams of Kool-Aid.
Right?
Was that?
So confused. Okay, so because isn't for the first part where it's saying to calculate what you have so far, so that's the 2.5 grams of Kool-Aid over, or do I need to make that into milligrams?
It's so
Milliliters.
the density of water is 1 gram per milliliter, so it's just 1 to 1.
It's a 1-to-1 conversion.
So 1 milliliter of water is the same as 1 gram of water.
Right, but I'm Okay, so what I'm trying to figure out is because you scroll up on the how to in the module, it's saying about mass equals percent of Kool-Aid over.
Yeah, because you're trying to calculate the percent mass.
Yeah. How much of the solution is Kool-Aid?
Oh, was that my dude Edgar on the camera? What's up, dude?
What's up, man?
Oh, I didn't know you were a gamer, bro.
Yeah, that's all I do.
You play Destiny 2 or what?
Nah, I quit Destiny.
I was gonna say, get that smoke.
I'm getting tired of it.
Outside of class. No, I was waiting.
Yeah, so for question number 6, it says the percent mass of Kool-Aid. So you got 2.5 grams of Kool-Aid and 100 grams of water. You divide it, and then you times it by 100 to get the percent. Or you know, you just know since percent is out of 100, 2.5 grams out of 100 grams is 2.5%.
Yeah, but that's the thing, because didn't you guys just say the grams of water is in milligrams?
Milliliters.
No, milliliters. We have 100
Oh.
milliliters in the solution, and 1 gram is 1 milliliter for water at least.
Okay, that's where the confusion is coming in.
All right, next we do add 10 milliliters of solution 1 to conical tube. What's solution 1?
That's
The
what
one
you're
you
gonna
got?
put in the bottom.
So put it back in the conical tube?
You're gonna put, yes, but you're only gonna put 10 mils in there.
Dr.
Well,
Henry,
Dr. Henry.
Yep.
Dr. Henry, if the formula for density is mass over volume, isn't
Yep.
like the mass I'm getting is 100 grams because like the volume of what we have is 100 milliliters.
That's right.
My mass is 100 grams.
That is correct.
Oh, that's correct. Okay.
1/4 teaspoon of baking soda. Yeet. You got it.
Harry, am I going to drop the like the dish soap into the 10 milliliters or
Yes.
into the bottom?
That's right. You're gonna put the dish up in the 10 milliliters, gonna put the cap on and kind of mix it up a little bit.
Oh, okay.
Let's see. Ooh, first one I grabbed was a 1/4 teaspoon, baby. I still got it.
Dr. Henry?
Yep.
Once we are done adding the 10 milliliters of solution to the conical tube, now we add the 1/4 of teaspoon of baking soda in the conical tube with the 10 milliliters.
That's after you added the dishwashing.
Wait, what was that again? I didn't hear you.
After you added 2 drops of dishwashing soap.
Oh, okay then.
So do me a favor, everybody. I want you guys to refresh because I'm modifying as you guys go because it, like I said, it was set up differently for the other class since they have.
Hey, don't pour the baking soda in your tube directly over to your computer because it'll bubble up.
Yeah.
Bubble up.
Yeah.
So where do we add the dish soap?
You add it to the conical tube.
Big volume measurements.
To the one with 10 mLs?
That is correct.
My volume went, when I added the baking soda, my volume went crazy all the way up to 50 milliliters.
How much?
Dr. Henry.
Yeah.
And the instructions, it says add 10 milliliters of, that's number 6, of Beaker 1 Kool-Aid solution to 100 milliliters graduate cylinder, and I don't have 100 milliliter graduate cylinder.
That's why I'm saying refresh your screen because it's being modified because you don't have a graduated soda.
Oh, okay.
Okay, so refresh it. If you hit the refresh button, it should give you the new updated version.
Bro, there's more steps when I refresh it. Can I go back?
No, that's exactly the point. There's supposed to be more steps.
All right. Now I got to make sure I did it right. Add 10 milliliter conical, add 2 drops of dishing. Oh, I already added the baking soda. I got to start over? Can I add the soap after the baking soda?
Well, the soap just helps you, the soap helps give you that true volume, where if you just add the baking soda, if you don't catch it at the very top, then it drops back down.
Well, when I added my baking soda, it went all the way up to 50 milliliters. It bubbled over.
Did it bubble over?
Almost.
Okay, then you need to repeat it.
Okay, so we measure it right when it starts and before it starts dropping.
Yep.
Okay.
Wait, so we're trying to catch the peak, but before it drops?
That's correct.
But how do you know what the peak is if it bubbles over?
Exactly. So that's why you're going to dilute it down. So you're making a dilution.
Oh, the soap will stop it from bubbling over?
Okay, if you read on, refresh the screen and read on.
If I refresh the screen, I'm gonna get more steps.
That's right.
Yeah, it says if not measurable, take 5 mils of this one, the new one, put it in a new tube and redo it. Or bring solution up to 50 mils.
Yeah, because you should have 2 conical tubes, right? 2 50 mil conical tubes.
I think my daughter's the conical tube. Yeah.
What if it was just exactly the top? Can I just count it as the 50?
What was that?
Mine went exactly to the top, so can I just count it as the 50?
No, because then you're gonna have to confirm it that it's actually 50. So you'll
I'm confirming it right now. Look at
You're
it.
confirming it right now. Okay, excuse me.
That's what happened to mine. But you're settled at that, Brittany?
Yeah.
Wait, now did it settle at that, or did it go over and then drop down some?
No, mine went, oh, it went just to the top and it settled right at 45.
Right at 45?
There's your answer, Brittany.
Are you sure?
Settling?
Set it on a level service.
Okay, yeah.
Have you never measured
Okay,
it?
it's dropping more. Is it so am I supposed to just keep watching as it drops?
No, you're not supposed to keep watching it as it drops, because that's what I'm saying. You want to catch it at the peak.
Yeah, so the peak was exactly at the top. It's just
Okay.
dropping.
But was it over the top or was it at the top?
I feel like Dr. Henry doesn't like the answer of it was at the top.
He doesn't, but my little orange Kool-Aid over here went at the top, Dr. Henry, not over the top.
Okay, so just for kicks and giggles, do a dilution. Because if it was at the top exactly, then you should be able to fall within that range. So if you do the next step, it'll put you in the range that you can actually get a good measurement.
So Dr. Henry, we could pour this out and we pour 10 milliliters of this back in it and we could start over with the soap.
Yeah.
But we don't need this anymore, all this extra?
So no, you want to keep the original. You got your one, your main one, right in the bottle.
But I'm pouring from this into the tube, so it's getting shorter and shorter.
That's right, exactly. But you're only pouring 10 mils, you have 100 to work with, right?
Right.
Okay.
So I could just do it again, is what I'm saying. We don't need
That's
all
exactly, yes, you can do it again.
All right. Because I thought we might need all this for something else, like we're gonna measure it.
Nope, you're gonna do a confirmation. I see it.
All right, I'm gonna do this one on camera so y'all can't even say nothing. Watch. Fresh tube. Blip. 10 milliliters. Boom. On the dot of solution. 10 milliliters. All right. Now we're gonna add dish soap, right? 2 drops of dish soap.
Right.
Oh, 2 drops, 2 perfect drops. And a teaspoon.
Whole ass teaspoon?
1/4 teaspoon. 1/4 teaspoon. Thank you, Edgar. Edgar, thank you. A heaping scoop or a level scoop? I remember that from home ec class. I'm gonna do a level scoop. All right, you guys ready? Watch, everybody watch. And you guys could take my numbers if you're too lazy to do it, okay? All right, we at 35. We hit 40. Now what? It's going slow. 41. Okay. So it stopped. So is that my number?
That'll be your number. So where did it stop at?
It's like right in between 40 and 42 and a half. So like I'm gonna say 41.
Okay.
Well, I'll say
Mine
40.
peaked at 45.
Mine's at 40 pretty much. Look, here, you tell me.
So yours is at 45. Okay, excellent. So the next thing I want you to do is You guys have your strips?
Yes.
Okay. So take your strips and take the pH of
What
the.
strip?
You guys should have yellow strips. I don't know what color your strips are.
Yeah, the
This one.
Hartnell.
We actually got yellow strips at Hartnell.
Yeah, Hartnell's got little yellow.
I got yellow strips.
Dr. Henry, at what stage is this? Is this after adding 10 milliliters of solution 1 to a conical tube, then you add the dishwashing soap?
That's right. So that's 10 milliliters of solution 1. And then you've already added the dishwashing soap? 2
I've
drops?
not added any of that.
Okay, add the 2 drops of dishwashing soap.
Okay. Okay.
Yep. Okay, and so what you need to do, you want to do confirmation of your experiment. You want to do it 3 times.
Okay.
Now that you've got your condition, so you have it. So you're using the initial solution, solution 1. You're going to do exactly the same experiment 3 times to make sure that your values are accurate.
So pour it out, put in soap, 10 milliliters of solution, and then the thing, and then measure.
So do this again?
Yep, you're going to do it again. Do it 3 times.
Why do you
So
have
want to confirm? Hey, you're going to be good scientists. We're going to talk about error and stuff. So 2 drops of dishwashing.
Yeah.
I'm doing it again.
Oh, we're going over.
You didn't add enough soap, bro. All right, 10. Dish soap. Blip. Blip. Whipping up the baking soda. I did say baking soda. Here we go. Remember when we did elephant toothpaste? Oh, this one's way taller. Oh, it's gonna go over the top. Oh no. Oh no. Oh no, 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 no. Oh shoot.
So mine stopped for a little bit at like at the 45 mark, and then I kind of moved it and it went over. Do I calculate with the 45, or do I just
No,
do it going over?
so that's the point. So if it went over, if it didn't flow out,
Mine went over the top this time.
okay. So that
Mine
means
didn't.
so did you get the same results, Vicky?
No, the first one was 50, the second one was 45. This one's like 43 point something.
Okay. So your first one was 50, the second was 45, and this one is like 43 point something. Okay, I would do it one more time. That third time, that'll be the third time. First time was working out the conditions. The second time was, what's that?
This is the third time.
I know, do it one more time. One more. Come on, you're gonna be a good scientist. You're gonna be great after I'm done with you. Okay,
So Dr. Henry, when do you use these strips?
I'll tell you when you guys need to use the strips.
Okay, for now we just keep doing this process over and over and keep recording the volume.
Yeah, so you're gonna do it 3 to 4 times, Brittany.
Okay.
3 to 4 times.
All right, I'm going on time number 4 here.
Wait, Dr. Henry, is it 3 to 4 times with the 5 milliliters or the 10?
It is 3 to 4 times with the, well, it depends on your condition. So like, for instance, Nate had one. If I were Nate, I'd hold up on doing it. Did you do the 5 or did you do the 10, Nate?
10.
You did the 10.
3 times, 4 times now.
Okay, so this is your 4th time with the 10.
Yeah.
Me
Right.
too.
So if your first time with the 10, right, was in the range of the conical tube that you can get a good accurate measurement, then you're good, right? So then you should be able to repeat that it's in the range that you can get a good accurate
Oh,
measurement.
you just made it 5 so it doesn't go over the top?
Yeah, so the next time it's 5 mils, right? But you're diluting it, right? So the next time you're going to dilute it and then you're going to repeat the experiment because then you want to find it in that range if it went over. If it didn't go over, you can use that first one. Do you understand? So let me
Wait,
draw
so
it up on the board.
You want us to dilute it with 5 milliliters of water?
That's right. Pick it up to 50.
So it should be 10 milliliters total still, but only 5 of the solution?
It's 5 of the solution, and then, yeah, still going to be 10 milliliters of, yes. 10
Okay.
mils. Did I mess that up?
See one that, so, okay, so this 4th time I'm doing it with only 5 Kool-Aid water with 5 regular water and then the soap and baking soda.
No. So the last, you want to do it the same condition. So yours still in a nice range, right? First one you got 50, exactly. Next one, you got 46, right? The next one, you said you got 43, right? So you would assume that this is your fourth time. It should fall within that same range. So you want to do it exactly the same way that you did it because you're able to measure it. The only time that you have to go down to a dilution is if you're not able to measure it.
Yeah, no, I'm good. I got my numbers now. What do we do after we got our numbers?
Okay, so you have your numbers recorded?
I got, yeah.
No, wait for us. Wait for me.
I have a question.
Okay.
Why if it's not rising
Yeah.
up? Is there like a
Dr.
trough?
Henry.
Yes,
Dr. Henry.
yes.
If we're doing the second solution, do I start in a new conical tube or do I use the same one?
You can use the same one. You can use the same one.
But the
and do
different
it there.
procedures? But the same
Yeah.
procedures as well?
But it's got to be the same procedures, but you're going to dilute it down first. So the first
Okay.
thing that you're going to do is dilute it down to 50. And then you're going to take 10 mils of that and put that into a fresh tube. You
Right.
understand? Okay. Yeah.
Yeah,
So
it's
your
50 from
first-
this, right?
Yeah. Well, if your very first solution that you tried went over, right? You only have to do it
Right.
if it goes over the volume, right? So if
Right.
it starts going out, then you're going to have to do a dilution. If it doesn't go over the volume, then you just record the volume.
Oh, okay then.
Okay. You got it?
Got it. Well, it's because I already did a second solution and it didn't go over the volume, so I would just leave it how it went.
Yep.
All right.
And
Okay, so
then
Dr.
you
Henry,
wanna-
I figured out this last one. So this one was 46.
Okay, so that one was 46, right? Okay.
Can I toss it out or no?
Yeah, so you can go ahead and toss it out.
All right. Wait, what are we gonna put our pH test strips in?
So you want to, after you've done it, well, sorry, where's Brittany? You want to take some of that food.
Brittany, don't toss it.
I thought you
I
did it.
decided to do it again. All right, so wait.
If it's in a sink, do you have a little bit of foam left in there?
Yeah, I have a little bit.
Okay, that's all you need is a little bit, right? So now what you need to do is put your test strip in there, just a little bit of your test strip in there.
Oh, it got
There
soaked
you
up. All right. It turned green.
Okay,
Second.
and then you want to match it up to. Did you guys get a little coder?
No,
It tells you the different pH.
I did
I'm
not.
assuming yours is probably the
No.
same.
No coders.
I
You
don't think mine works. Mine just looks like a wet strip.
It just looks like a wet strip. That's good because it should be neutral at this point because you have an acid and you have a base, right?
Mine's like bluish
Oh,
green.
mine is green.
What was that?
Mates is green.
Yeah,
Okay, what color was your Kool-Aid?
blue.
Blue? Okay, do me a favor. Rinse
Yeah.
both your strips off with a little bit of water, just a little bit.
Like the part I dipped.
What was that?
The part that
Yeah. The part that you did.
All right. I ripped my strip in half.
What was that?
I ripped my strip in half. I gotta start over.
That's all right. It's okay. If it's stripped in half, that's fine.
No, but it like ripped in a bunch of little. I put too much water. Here, I got
Okay.
enough.
Okay,
Alright.
so do me a favor. Just take a little, rip off a little piece of it.
This. Rip off a piece.
Yep. Okay, now just use that to dip in there.
Yo, the last time I had a piece of paper this small, I can't even tell you what happened. Hey, you guys ready? You guys ready? Let's go. All right. Here. I can't, my fat fingers don't fit in the tube. All right. All right, it got a little bit.
Okay, so do you have your vinegar?
I do have vinegar, yeah. White
Okay,
vinegar.
so you have your white vinegar. So do me a favor, take another little piece of your tube and dip your white vinegar in that.
Take another little piece of the strip and dip it in white,
Strips. Yeah, thank you. Strip.
dip it in white
That's a
vinegar.
lot of message. Yep. Let me see. Let me read the
I don't
messages.
have that comparison pH thingy you were talking about.
Yes, you add that 50 mils. Sorry, Victor. Yes, you're supposed to add the 50 mils to the water bottle, the empty water bottle.
That's because Hartnell printed our strips in freaking black and white.
Did they really print them in black and white?
I know. I don't know.
Okay, so on your back, it should be on the back of one of your sheets, there should be a strip. It should give you the code to the strips, the pH code to the strips.
We look them up online because I don't think they gave them to us.
Yeah, you can also look them up online.
Yeah, I don't think I have it either.
All right. This one turned like orange. The vinegar one.
Okay.
All right, I got them right next to each other.
Okay, so now do me a favor, take some baking soda and some water and mix it together and then check the pH strip with that.
Just baking soda and water? Does it have to be this distilled water?
The distilled water helps because it's about the right pH.
So use
And then-
this
Yep, just a little drop of it
and put baking soda?
and put baking soda.
All right.
Dr. Hiroki, I know you talked about this, but if we go over, like if it bubbles over it, you add 5 milliliters instead of 10. Is that right?
Okay, so if it
Of
boils
this.
over, if it bubbles over, you can get away with adding 5 milliliters. And then, but if you're gonna go add 5 milliliters, bring it up to 10. I'm gonna make the adjustment on the thing. But let me
With
write up-
water. Like you just put
Yeah,
5, you put
with
5
water.
milliliters and then add 10. The rest of, okay. All right, I
Yeah,
got
so
you.
then you're diluting it by a factor of half, right? Rather than 10. So that,
Baking soda. Ooh.
Hey, Dr. Henry, how many times do we need to do the test with the tube?
2.
you want to do it at least 3 times.
Okay,
4
so
times
I've done
would
it.
be perfect.
I did,
If it goes over at any point, you want to work out that condition, right? You want to try to get the condition right. For the-
yeah, I got it down to where it's in the 30s basically every time now.
Okay, good.
Okay, so then what do I do after that? Do I put the pH tester in there or something?
Yep, so you want to do the pH tester to see what the pH of your solution is, because it should technically be neutral if it's been neutralized, right?
So I want to put it in the actual fluid, not the foam, right?
Yeah, well, the foam is better. The reason why the foam is better is because some of the fluid is going to have a lot more color to it. And it changes pH to
All
that
right, I
color.
did the baking soda and water, and it's way darker than my Kool-Aid mix.
Yeah,
Okay.
So my strips are basically coming out dark green, and according to the online, that's like around 7, 8. So it should be right?
Yep.
Awesome.
What did you say it is, according online?
Just the first one I saw set like dark green or light green is around 7 or 8. Because none of mine have overflowed, so I've been using the standard 10 mils.
What, 7 or 8 pH?
Yeah.
Yeah. What about, do you have the chart up? What about orange?
Orange looks like
Let me put the chart up right now.
5. They're all different too. Like this one orange is like 2, and this one orange is like 4.
Yeah, it just depends.
Dr.
on
Henry,
Yes,
I know you are well past this stage right now, but I'm sorry for bringing you back. I just
no,
have
that's
to.
all right.
Okay. So after the second time we okay. Number 16 says, if not measurable, the 5 milliliters of new solution to the conical tube and bring solution up to 50 milliliters by adding H2O. I'm really confused. Is it the second solution?
Yes, that is the second solution.
Oh, okay. As you can see, mine didn't react.
It didn't
I don't
react at
know.
all?
Yes, no reaction. Actually, I am not using Kool-Aid. Like, I couldn't get it here in Nigeria. But there's something very similar to Kool-Aid we use. It's called Fresh.
Does
Like,
that have citric acid in
Okay.
it?
So what does
Yes.
fresh have in it?
you said?
Okay, what does fresh have in it?
Okay, Fresh has okay, sorry. Sugar, acidity regulator, citric acid E330, trisodium citrate
You say
E331.
acidity regulator?
Here, it says
Yes.
citric acid as a third ingredient. Maybe it's not enough.
Okay.
Yeah, so
Acidity regulator in ours.
so in other words, if you have an acidity regulator, so then
Yeah.
basically you're getting rid of the acidic property. So it's making it more neutral.
Oh my God, are you serious?
Yeah, so in your case, it isn't gonna work because, so do you have lemon juice or?
Oh no, I don't have lemon juice. My lemon tree just stopped bearing. It's not the season.
Okay,
So I
do
don't
you
have
have
any.
any type of juice?
Well, oh no, I don't. That type of juice will not work. I wanted to say I have ginger juice in the fridge, but I don't think so.
See.
You can use
Um,
Well, you
that
could always record it at home.
do you have a soda?
God. Dr. Henry, is there something I could do? The first one reacted, but this one probably is just too weak. The second one.
So if the first one reacted, then use the
Yeah.
first one.
I should use the
Did-
first one.
Did it overflow? Did the first one
No,
overflow?
it didn't overflow. Not at all.
Okay, so then use the first one. So
Okay.
what you basically have a drink that has neutralizer, so it's not as acidic as it normally would be. You're not going to
Oh
get
my God.
all the good results. It'll be a little bit less acidic then.
Okay.
Okay.
Probably better for
Okay.
you. anyways.
Dr. Henry,
Yes.
in part two, when we're trying to weigh out the 1/4 teaspoon of sodium carbonate, which is the baking soda, which test tube are you referring to the 15 milliliter conical tube or the 50 milliliter conical tube?
The 50.
50, but like a clean one or the one that we were using right now?
Use a clean one. 'Cause
Okay,
you
then.
have two, right? Okay, so how many of you guys still have your what is it called? Your cabbage indicator.
I do.
I do.
Okay. You have 15 mils of distilled water.
Yeah.
Yes.
Okay. So what you
My
want to
cat.
do is, what was that?
Right here. Blip. pH indicator red cabbage
Okay.
and 15 mils of distilled deionized water.
Okay, so what you want to do is put your cabbage indicator into your 15 mils of the DI water. So remove, so if you're putting in 1 gram, you need to pull out 1.5 milliliters of your water.
Or else it'll overflow.
I'm sorry, could you repeat that?
So if you're putting in 1 gram of your cabbage indicator, then you need to pull out one milliliter of water, roughly.
Is this string so that we could like centrifuge this thing?
Can you repeat that again?
There's a string in my bag. Is it so we could like centrifuge
Yeah,
it?
that's what I was thinking. This thing, suck up
Yeah,
the 1 gram of water.
So technically you could centrifuge it, yes, but you don't need to.
Oh,
I don't know why the string is in your bag.
I'm about to do it right now.
Me too.
Yeah, baby. Everybody record. This could end up on YouTube. Get red cabbage water all over my kitchen.
Okay, you also want to record the water. Record the color of your red cabbage.
Red like bad
Before I
Kool-Aid.
mess this up, we're just adding that red cabbage water to this 15 one.
Okay, so now before you mess it up, you're gonna add the red cabbage powder to the water, to the distilled water, 15 mils.
Here we go, baby.
The full 15 mils of water?
No, so you want to remove a mil if you're gonna add a mil of red cabbage. So if it's 1.5 mils, you need to remove 1.5 mils of water, right?
Yo, look at that mix I got from the centrifuge, baby. That's a good mix.
Let's see.
Dr. Henry.
Yep.
Sorry, I was asking. Number 16. I'm not clear about it. If
Okay,
not
hold on.
measurable, if not measurable, the 5 milliliters of new solution to a conical tube and
Okay.
bring solution up to 50 milliliters by adding
Okay.
H2.
So what I
Also,
mean by if it's not measurable, if you can't
What?
measure it, that means you have to dilute it down. If
why
you
would
can
you
measure it, you
measure
don't have to dilute it down.
All right, this is
Okay.
dark blood red right here.
Okay.
Okay?
I get you. Yeah.
Okay, so did you record the color?
Dark blood red.
Dark blood red. Okay? Perfect. Perfect.
Wait,
What about yours?
a pH strip or just the color?
No, the color's perfect because it's an indicator. I'm gonna put on the screen what it should look like. Hold Hold on, I'm gonna put it up in the lab.
Does it take a while to become red?
It doesn't take a while for it to become red.
I'm
Yeah.
asking.
No, it shouldn't. It should be red.
I spun my
Dr. Henry, I'm kind of,
My
how
is
much of the lab?
What was that?
my is color purple.
Yours
Me
is
too.
purple?
Maybe I got the fake stuff.
Okay, hold on.
Y'all
Yeah, so that, remember I told you, when I tried it, it didn't quite work out the way it was supposed to? I bought a big old thing of beets. Let me pull it up, hold on.
I tied this to a string and I swung it around in a circle over my head to mix it. Maybe that's why it mixed better than y'all's.
Yeah, let me do Nate's ritual real quick.
Okay, that is not, you gotta get the centrifugal action, you know what I'm saying? You gotta swing it on the end of a rope so that the centrifugal force at the end is stronger than what your pivot point, you know what I'm saying?
Have some cookies.
Dr. Henry, we add in the 15 mil thing, we add the whole thing of the cabbage stuff.
You wanna add,
To
so
it?
you wanna remove about 1 ml of water, 1.5 mils of water. Because you don't want it to overflow.
Oh, so you just like say down to like 14 or?
Yep.
So what do we do with this now?
Okay, so that's what I'm getting to right now. I'm putting up the indicator.
Heated it into the
Hey,
sink.
Dr. Henry, mine didn't come with the water in the tube.
Yours did not come with water and tube?
Nope.
Not even in your big one.
You didn't have water at all, so it must have. Oh,
Oh, I have one in a 50 milliliter one.
yes,
I-
use that water. Yes,
Just use that water.
yes.
Okay.
Mine came with two, bro. They
That's
probably gave
the water I have too. All my water came in the big 51.
So yeah, so just use that water.
Were we supposed to get two?
How much
Okay.
do you have to add of this?
What was that?
How much you have to add of this? Just all? Do we pour all of it in or just one?
You pour it in. Yeah, it should be roughly about what you need. So you want to make sure that you have enough room for it in your, yes.
So for
Can you
those of
repeat
us who
the
didn't have
last
it,
part, Dr. Henry? I'm confused. Like with the cabbage? Like
Okay. I'm gonna draw a picture for you guys, okay? Now don't make fun of my first grade drawings there. Okay, so here's your tube with the cabbage, right? This is cabbage.
Pour it into the water.
Okay, you have a 15 mil conical tube.
Put the cabbage in the tube.
So you're gonna remove 1 mil of water so that you have enough room for your cabbage, right? So at first, your water's gonna be all the way to the top. Remove just 1 mil of water, and then you're gonna take your cabbage and you're gonna just put it in the tube. And then you're
Wow.
gonna mix it.
You became a doctor for this.
Shut up, Ace.
All that schooling came down to this.
Okay, so now we have the tube. Okay, so now you guys are ready to use the tube, right? So one thing I want you guys to use the tube on is your Kool-Aid. So you guys have concentrated Kool-Aid. You still should have a little bit of solution 1 left. Is that right?
Yeah.
What color is your Kool-Aid right now?
Blue.
Yours is blue. Okay.
Yep.
So I'm gonna put up on the screen the cabbage indicator. Let me share my screen. Hold on. At the different pHs.
Was I supposed to get 2 of these tubes? Because they gave me 2.
Yeah, you are.
Okay. Oh, shoot. Mine is way darker than all of those.
so for us that it doesn't react at all and just stays like that cute color purple, then what?
My is number 4.
Yours is number 4.
Yeah, mine's
Okay.
the same.
Yours is number 4.
Yeah, mine's just a
Pretty
purple.
lavender.
Wait. We put the cabbage to the Kool-Aid now?
Wait, hold, slow down. Let me tell you, you're gonna put a little bit of the cabbage into the Kool-Aid, okay? So
Right
right now, your number should be somewhere between, because you guys put it in water. And if it's distilled water, it technically should be at 7 pH, which should be a purple color. Purplish, bluish color.
Mine is like dark blood red. I don't get that color at all.
Your color is this right down here.
Look at it. It's on the screen. You can see it.
Okay, hold on.
I mean, it literally looks like a vial of blood.
Okay, Okay, so that probably means that the water that they gave you was probably not.
I guarantee you, Brian Salinas, they just went over to the sink and they filled them up and they just yeah, guarantee.
Okay, so they should be around the purple, right? So your Kool-Aid, what are you expecting your Kool-Aid to be?
What do we?
Kool-Aid is like that greenish side.
Okay, so if you put, so I'm gonna put a little bit of your Kool-Aid.
All right, I'm going.
Could it be blue?
Nope. Okay, and what color
We
is it
put
turning?
on whatever's left.
What was that?
We put on whatever's left.
Not the whole thing, just a little bit. Put in about 2 mils.
It's like purple.
Okay.
It looks really good, actually.
So it's about a 4 pH.
No, it's a little darker, more like a 5 or 6. But I
Okay.
have dark blood red cabbage to start with.
Okay.
Mine didn't really change much.
Salinas.
Yours didn't change much.
Yeah, like mine was like a bright orange. Now it's just like a dark orange.
Okay, so get a conical tube, put a little bit of vinegar, put the vinegar in there, and then pour a little bit of your cabbage juice into that vinegar.
All right, I can do that.
Okay, and then after you do that, rinse it out again. Get a little bit of baking soda in there.
Baking soda, vinegar.
And then
What were the
anything you think of that you want to figure out the pH of.
We use the cabbage. All right, here we go, baby. This is vinegar. All right, let me record my data real quick, though. Cabbage water.
Okay, so what do we do? What if, like, mine didn't really, with the, like, Kool-Aid didn't really change colors. When I
Okay.
put that
Dr.
in.
Henry?
Yep.
Is there anything else I need? Because I need to head out right now.
Okay, nope, that's it. Have you done the vinegar and with the cabbage juice?
Yeah.
So then you're good to go.
Okay then. In the report, do we tell you the colors how of our changed?
You want
All
to
right.
tell me the pH. So tell me the color and the pH that you got.
Okay then.
All right, I'm doing cabbage in vinegar.
Dr. Henry, one more question.
Yep.
Color.
In the group project, there's one assignment due today. It's the
I'll
chem.
fix it. It's all due on the 17th. I need to
Okay,
fix that.
which is on Monday, right?
Yep, everything is due on Monday.
Okay then.
All right, I got 2 here. So this is a 2.
Okay, Henry, how much vinegar were we supposed to do for the cabbage juice?
Yeah.
All you need is like less than 5 mils, and then just pour cabbage juice in there.
All the rest of the cabbage juice? Or
No,
just
just a little bit. 5 mil.
Put it away. Thank you, love. Oh, you're welcome.
Did it change color?
Hey, Dr. Henry, how much of the cabbage solution do we put in the Kool-Aid?
So you need about a mil or 2 in the Kool-Aid.
And that goes into the main one, right? The main
And you
solution.
can go ahead and put in the main solution after you've already done the experiment. Yes.
That's just the repeating it 3 times, right? Basically.
Yep.
Okay.
All right, cabbage is now going.
Yeah, Dr. Henry, the vinegar and it still stayed that same like really
Purple color?
pretty color.
I'm
It's a
in-
pretty color, but it's not a changing color.
Okay, so we're not getting any change. So you're about, it's still around 4. 4-ish.
Yeah.
Oh, it's like blue. All right, baking soda made it turn like blue, like 8.
Okay, so now what you're gonna do is take that conical tube,
Yeah.
rinse out your conical tube, put water in there and put baking soda in there. Okay,
Water and baking soda?
and baking soda, and then add some of the cabbage to that.
That's what I did, and I got dark blue, like 8.
Am I test stripping this stuff too or no?
Yeah, you can test strip it to verify it.
Wait, so layout. So this is the part where we do the quarter teaspoon of baking soda.
Yep.
With water.
So baking soda, water, Cabbage gave me an 8. All right, 8 pH, baby.
For the baking soda,
Dr.
are you
Henry.
using distilled water or faucet water?
Oh my God.
You should use, I would use distilled water because your faucet water is going to be slightly off. Your distilled water technically should be right at 7, technically.
Dr.
Is that,
Henry.
What was that?
are
Yes,
those
Mary.
the last?
Okay. Dr. Henry, so okay, I'm a little bit worried, like I'm quite behind and all that. Well, at this stage where like after number 21, you say this number 1, you say add 10 milliliters of Beaker 1 Cool Aid solution to 100 milliliters graduate cylinder. Okay, so like since my solution is very weak, I am worried because that's going to kind of over dilute it. So what do I use?
Okay, so slow down. The only reason that you would need to go further is if your solution, if you ran over. So are you listening to what I'm saying? So if the experiment didn't work, if it flowed over, then you need to dilute it down. If the experiment worked and it didn't run over and you were able to get a volume, then you're okay. Okay. So you can stop after the first, time. Now all you need to do is verify the results by using the same procedures that you did 3 times. Try to see the data that you got is accurate.
Really? I should do that 3 times?
That's right. 3 times.
Okay, then after that, what happens?
Okay, so then after that, you're going to record the data, right? So then you're going to use that. You're going to record your mass, your percent mass, the one that you're actually using. You're going to record the percent volume, and then you're also going to record the volume that you actually got. And you're going to use the volume to calculate the number of moles that you have for your acetic acid. Your acetic acid.
Okay. Okay, so is that where part 2 says using volume of gas generated to calculate moles of citric acid?
That is correct.
Okay, so the gas here is oxygen.
That's right. So based upon the chemical equation, the gas is carbon dioxide, right?
Okay, carbon dioxide. Okay.
Yeah.
Carbon dioxide.
All right, Dr. Henry, after we do those 3 test strips, that's the end? Or the 3?
Yeah, that's it for right now. That's all you need to do for the acid base. I'm going to put in my calculations, the lower part of your, how you can calculate the amount of acetic acid that's in your Kool-Aid.
Okay.
And then you guys are going to submit, you're going to show me your work and submit your answers. And based upon your answers, you will get a grade.
All right, so you're going to add that part 3 to it later, and then we just look at it and put our data in there?
Yep.
All right. Thank you, guys.
I'm adding to it right now. Yep.
Dr. Henry.
Yes.
I'll later.
What is okay? Test tube 1 is the first stuff we did. That's the 10 milliliters.
Do me a favor. Refresh your screen right now.
Okay.
Dr. Henry, what do I do with the vinegar part? I didn't follow that part.
Okay, so what you're going to do with the vinegar part is that you're just going to test the pH of the vinegar. So you want to test the pH of your Kool-Aid. You want to be sure that your indicators are working, right? Can you hear me? Is it breaking up?
Yeah, it's kind of breaking up a little bit.
Okay. So let me put up a whiteboard and I'll show you what you guys can do. It's the easiest thing.
Dr. Henry, none of my indicators worked for anything. It stayed that same lavender color purple. So just notate that on my stuff.
Yep, just notate that on your stuff. That means that we need to get better indicator. Okay, so this is your indicator here, right? They're going to be adding it to your Kool-Aid. You're going to add it to your vinegar. And then you're going to add it to baking soda.
So we just like straight vinegar?
Yep, just straight vinegar. So 5 mils of your straight vinegar. You're going to add 1 mil of this guy. To your Kool-Aid, you're going to add 1 to 2 mils. And then to your baking soda, you're going to put baking soda and then you're going to put 5 mils of water. And then you're going to add 1 ml of indicator to that.
Dr. Henry, Kool-Aid, 1 to 2 milliliters of water.
No, 1 to 2 milliliters of your pH indicator, your
pH
cabbage
indicator.
indicator.
Okay. What of vinegar?
Dr. Henry, how much vinegar do we put on this?
On what?
You said to put it on in here, right?
In your conical tube, yes. Put 5 mils of vinegar in your conical tube.
It's going to be for the last solution, right? This one, like the one that you're showing us?
Yeah, so this is your cabbage indicator, right? So you made your cabbage indicator. So you have your Kool-Aid that you had initially. So what you want to do is drop 1 or 2 mils into the Kool-Aid that you had left over. And then you want to record the pH that you think it is based upon the color change, if there was a color change. You want to do the same thing in the case of the vinegar. And then you want to do the same thing in the case of the baking soda.
Basically 3 times.
Yes, 3 different times. Yep, 3 different things.
Okay, I did
Yep.
that right.
Okay, and then you can test anything else you want to test, just to see if it changes.
Okay, so just to be clear, in the middle is 5 milliliters of vinegar.
That's right.
Okay.
Okay, Dr. Henry, after I get all these numbers, that's the only information I need, right?
That is the only information that you need. Yes,
Yeah,
you got the
because the
volume.
actual, I'm sorry?
I said you got the volume of your, how far it bubbled up, right?
Yes.
Okay, so that's going to allow you to calculate the number of moles of acetic acid. Okay, that volume. So if you look at the bottom of the page, it should say volume. Make sure I'm not lying. It'll say V equals K N. And let me give you the value. I did give you the value of K. So.
Is this all going to an Excel sheet or?
You could do it in an Excel sheet, or you could just do it in a simple lab report, because I guess there's a couple of calculations. There's no need for a graph, unless you guys want to just show me your error that's associated with it.
Dr. Henry.
Yeah.
Okay, so for part 2, it says weigh out a quarter teaspoon of baking soda and put in test tube 1. Are you like going to?
Oh, okay, so that's what I'm saying. For some reason, let me see why. Oh, let me fix that. Don't do that. You're done.
Okay.
Yeah, don't worry about that part. Yeah.
Actually, somehow didn't make sense.
Yeah. Let me fix that right now. Yeah, so because you guys don't have test tubes and you don't have a graduated cylinder, so.
Yeah.
So I had to modify the lab.
Okay.
Just to clarify, the baking soda is a quarter, right? Quarter teaspoon. And then 5 mils of water.
Of water, yep.
And then you said it'd be best to use the distilled, right, water?
Yep.
Or doesn't? Okay. Yeah, I'm basically I'm for all 3, like for the vinegar and the.
It's not doing anything.
It's both the exact same pretty much. It's like a 4.
Okay, so there's something wrong with that solution, and so that means I have to dump it out. At least it about $50 on it.
Yeah, I got 3 on all mine basically.
Okay. Okay,
Yeah,
well,
mine is
just
full.
record it. So now, well, before you record it, but then also use the test strips. So the test strips should tell you the truth, and I'll give you the indicators for the test strips here. I'm putting that up right now too.
And then in my Kool-Aid, it didn't because I have like a red Kool-Aid, and it literally didn't do anything to it.
Okay. So yeah, there's something wrong with it. So just make note, there's something wrong.
Dr. Henry?
Yep.
if I got the 3 colors already, what should I do, or what's next?
So if you got the 3 colors already
Yes.
for the indicator,
Yes.
that's it. That's all you need to do. You just need, you can let me know the colors, and then I'll put a key on the lab itself. I'm putting it up right now so that you guys can determine the pH.
Okay. And then one more question. So I got the 4 times doing the results. I got the 4 times. So are we gonna use all of them or just one?
You're going to use all 3 of them. You're going to take the average of it.
Okay. So that's it, right?
Yep.
Okay, thank you.
Okay.
Dr. Henry, I'm really confused. Like, I've been sitting here trying to listen, but I'm like very lost. I did problems 1 through 10, and then I got 43 milliliters, 45, 43, and 46 for my test 1. And then I did 11 through 14, and I'm trying to.
So you don't have to do 11 through 14. The only time that you have to do 11 through 14 is if your first ones didn't work.
Okay, you were saying that, and I was very confused still. And then, okay. So did I need, well, I have to do it again because that's what we have to test, right? With the test strips?
No, what you need to test with the test strips is that test your Kool-Aid. You want to test your Kool-Aid, you want to test vinegar, and you want to test baking soda. That's different.
So solution 1 is what I'm testing.
Yes, your solution 1.
Okay.
Yeah.
But
I had Nate and them tested earlier because technically it should be neutral, right? It should be a pH of 7 because what you're doing, you're having an acid and you're having a base. So baking soda is a base, it's a weak base, and then acetic acid is a weak acid. So what you're doing is that you're adding a weak base and a weak acid. It comes together, you should have basically water and a salt. So you should get a pH of about 7.
Okay, so number 20, what would solution 2 and solution 3 be?
So that's if you needed to use solution 1. Let me write that in there. Solution 2 and 3, if you need it.
Okay, see, I was so confused. And then, so 21, we'd only do it for solution 1 if I didn't need solution 2 and 3.
That's right.
Okay, so test strips for the solution 1, vinegar, and baking soda.
Yep.
Okay, thank you.
Dr. Henry, I'm having the same problem because I was listening and I was getting so stressed out. I'm still doing like the one that she just said. So it was 7 through 10.
Okay.
And then so it's starting to go down, but it went a little bit above. Oops, it went a little bit above the 50. So like what I say, like 50.
Okay.
Go all the way to the top. It just went a little bit above the 50.
Okay. How many times have you done it?
This is my first time. It's because I was trying to watch everyone.
Yeah. Then do it again. So do it again. Do it, if it goes above 50 the second time, then you're gonna have to dilute it.
Okay.
Okay.
I can empty out in the sink, right?
Yep. What is that? You can put it on the sink. Yes, it's just Kool-Aid and baking soda.
Okay.
I pour the whole cabbage into one thing of the deionized water, but I take out a milliliter, right?
Yes, that's right.
So Henry.
Yep.
What am I actually going to be testing with the cabbage and stuff? Should I repeat exactly what I did with the first test tube?
No, it's different. And in the case of the cabbage, the cabbage indicator, all you're doing is checking the pH, right? We want to determine the pH. Okay, we want to determine whether or not it's a strong acid, if it's a weak acid, so you need to determine the pH. That's all you're doing with that. Okay.
Okay, determining the pH of what? Am I going to set up the test tube again?
Okay, so again, listen, Mary. Okay, this is what you're going to use. You're going to use solution 1.
Okay.
You're going to use vinegar because you know that vinegar is acidic, right?
Okay.
Okay, and then you're going to use
baking soda.
Baking soda because we know that baking soda is basic.
Okay.
Okay.
Okay. So just to be clear, 1 to 2 milliliters of again.
Yeah. So then you're going to use 1 to 2 milliliters of your cabbage indicator.
Okay.
Okay.
I didn't. Okay.
Okay.
Is this liquid?
What was that?
Is liquid? Is the indicator liquid?
No, the indicator is a powder. So you need to put the powder into the 15 mils of water. So you have a 15 mil conical tube. Is that right?
Okay. Okay.
And then you have a 50 mil conical tube that has water in it.
Okay.
Okay.
So I put. Okay.
And so what you're going to do is put the cabbage indicator in there, and then you're going to fill it up with water. And then you're going to mix it.
So when I do that, I put this indicator in the 50 milliliter conical tube. So I take 2 milliliters of that into my first solution.
That's right.
Okay. Then the second one is
record the color change.
Record the color change. Okay.
Yep.
How do I know the color change? Okay, I would see the color to be visible.
That's right. Exactly. Yes. Yes.
Okay.
Yes.
Could you update Hartnell's canvas? Because I think you put the pH for the other one, but I don't see it on ours.
Okay, let me save it. Do you see it now?
Yes, now I do.
Okay.
So I remember Nate was saying his was kind of like a blood color.
Yep.
Mine's like the same.
Okay, that's fine.
Do I have to indicate the pH of this? I'm confused.
Yeah, so what is the color that is starting off with?
Well, that's a good question. I want to say it's like it could be red or it could be a very deep purple.
Okay, so it could be a red or a very deep purple. So somewhere in here, the 1 and 2 area.
Okay.
So then record what you have, which is weird because your water, that means your water is very acidic.
Yeah, that doesn't make sense if it's distilled.
Dr. Henry.
Yep.
Is it all the pH indicator that I'm going to put inside the 50 milliliter water?
Yes, you're going to put the whole thing in there.
Okay.
So then,
So Dr. Henry, all I need is the pH, basically the pH indicator from the cabbage and the strips for each one of those solutions.
That's right.
And then other than the measurements, that's all I need, and then I'm good to go. And then I just do the calculations.
That's right.
Okay.
Yeah.
All right.
Okay.
oh my God, I'm so lost. Wait, am I supposed to be? Oh. So I use the strip to determine the pH.
You're going to use the cabbage indicator and the strips to determine the pH. Both of them. They both should do exactly the same thing. They're both indicated, right? So the way it works is there's a couple ways of doing it. One way that you could do it is you can add an indicator to your solution, and your solution is going to change color based upon the pH. Now the problem is that if you're at Coalinga, we got hoodwinked. We bought cabbage indicator in bulk, and it wasn't cabbage indicator. It was probably beet juice or beet extract. And so it doesn't change. It only changes 2 colors. It'll change a red color, and it'll change a blue color, a really dark blue color, because beet will only change 2 colors, where cabbage will go from all the different colors that you guys see up on the board right here, depending on the pH. Okay.
Okay.
So wait, hold on. The next thing is that the strips do exactly the same thing. Only thing, they use a different type of indicator, right? And so I'm going to put the strips on there so you can compare your strips to those colors too. So you want to record the color of your strips, and then you're going to find that color on that indicator, and it'll tell you the pH that you have. Does that make sense?
Yes.
Okay. So now if you have an acid and a base, you have a strong acid and a strong base, you put them together, you should get water and salt. That should be neutral, right? If you have a weak acid and a weak base, you put them together, it should also be neutral, okay? And so the thing that you did today was you have a carbon acid, right? So citric acid is a carbon acid. Is that a strong acid or is that a weak acid?
Wait, for which
Weak
one?
acid.
It's a weak acid, yes, because we know that
Yeah.
all carbon acids are weak acids,
Yeah.
right? And we had baking soda, which I'll tell you, it's a weak base, right? So when you put those two together, you should also get water and a salt, right? And so that should also be neutral if it balances each other out completely. And so what you guys are doing, you're basically adding excess amount of baking soda. So your pH should be roughly around 7-ish, 8-ish in that range, right? Because neutral is 7 and 8 would be slightly basic. Does that help?
That's what I got.
So Dr. Henry,
Yes.
what is the strip, the yellow strip going to tell me? Like, what am I going to use to know my answer?
What did I just say? The yellow strip will tell you.
I think pH.
That's right. They're pH indicators. So
Okay,
it should tell you the actual pH. And so it's a way of comparing because, you know, we have the cabbage indicator. So technically the cabbage indicator should work, but we know that the one in Coalinga does not work. But pH strips do work. So we should be able to sit there and compare the results of it. So they should tell you exactly the same thing if they were both working. But since one of them is working and one of them isn't, one will tell you what you need to know.
Okay.
Does that make sense?
So, yeah. So what should happen to my pH? What should happen to my yellow strip? What color should show me acid and not acidic?
That's if I'm trying to get that put up there, but I haven't been able to get that put up there because we've been talking. So
okay,
the indicator's up there so you'll be able to see what it looks like.
Okay, Henry.
Yep. You're breaking up on me.
Oh, I was just saying that I was gonna let you finish what you needed to upload.
You have something to upload?
No, for you. So that way I can ask you a question.
Okay, thank you.
So should like the vinegar be like a 5 or a 6 roughly?
The
pH?
vinegar should be around a 4, 3 or 4. 5 or 6, yeah, 3 or 4, I think, roughly.
Okay, I'll just do a quick little test around it real quick again. Because how long are you supposed to leave it? You're supposed to let it sit, or you just get the instant?
No, with the strips,
Yeah.
it's pretty instant.
Okay, yeah. It is set for a little bit. Okay, I would say it's almost perfect with around 4.
Save and now.
Okay, Henry.
Yep.
So both for the step 7 through 10, all 3 of them went over the 15 milliliters.
Okay, so then what you want to do is you want to take 5 mils
Okay,
as your original solution. Yep.
okay.
Take 5 mils of that, and then you're going to dilute it. Because last time you used 10 mils, right?
Yes.
Okay, so what we're going to do, we're going to just dilute it by half, and I'll adjust it on the lab report. So
I do the same steps. I added 2 drops of soap and
yep.
1/4.
Yep. So, but what you're going to do is you're going to add put 5 mils of water so that it's 5 mils and 5 mils, so a total of 10 mils.
Okay, so you add the 5 of the solution and then 5 of the water.
Yep.
Okay, because it says 50 milliliters.
Yeah, but if you do 50 milliliters, it's going to be too dilute because you're just a little bit over.
You're cutting out. Sorry.
I'm sorry. I said, if we do 50 mils, if we dilute it by 50 mils, and initially I was going to dilute it by 50 mils, but we know that you're just a little bit over, right?
Yeah.
Okay, so if we dilute it by 50 mils, it would be too dilute, and then you wouldn't get a really good reading, right? And it'd be inconsistent. So by you cutting it in half, it's a better dilution. So I'm gonna adjust that on the lab.
Okay.
Yeah, okay.
Okay.
If
So
I
for
can get the
my
lab show.
pH, the strip, it was kind of like an orange, so I put it like a 2. But when I
Okay.
used the cabbage indicator, it was more of a 1. Like it's really red still.
Okay, so then just record both, you know?
Yeah.
It's okay.
And then vinegar, the strip, I threw it away. It was like literally the same color as 14, but I know that's wrong because vinegar is not
Yeah.
alkaline. But the color of it when I did the cabbage is like a 2. So I don't know that my strips are very
Accurate.
Yeah.
Okay. Well, just record what you have, and then do you have any more of your strips left?
Yeah, I have a bunch.
Okay. So just test it again.
Okay.
All right, so I have just to make sure I have everything. I have like my 3 different measurements from the tube for the foam, and then the pH for the Kool-Aid, baking soda, and vinegar. And then technically I have the acidic test or whatever, but it's not going to be, I guess, usable. So is that all we needed, right? Was that those 3?
So we take out where it stops at, right?
That is correct.
Okay.
So I did it again for the baking soda, and the strip pretty much it worked. It gave me like a green, so I put like 11, and then the cabbage gave me a blue, like an 8.
Okay.
So that one works, but then I did vinegar again, and it's still kind of giving me more of an orange yellow. Should I just assume it means more of an orange red?
Orange yellow? No, it's fine. Oh, it's also diluted. Remember that, right? So it's like 3% or 5% acidity, right? So that's fine if it's an orange yellow. So that means between 4 and 5 instead of between 3 and 4.
Well, no, it more towards the alkaline side, which is weird. Oh, it's kind of switched. Yeah, because on the indicator for the red oh shoot,
This is for the pH strips.
I'm not even on the strip one.
And this is for the red cabbage.
Yeah, let me see. Should I re-upload?
So my first, for the second, like the first 2 tries, I've gotten 35. Should I do it one more time?
No, the first 2 tries?
Yeah, the first 2 tries have been 35.
That's perfect. Do it one more time, and then you have your 3 data points. Good.
Okay.
Dr. Henry.
Yep.
After noting all this stuff, the color change, what's next?
Then you're good. I'll just
that's
put up, you'll answer questions. I'll put the questions up. I'm in the process of fixing that now because I have to modify it because it was for a different type of lab that you guys are doing.
Okay.
Okay.
That's all right.
Okay.
Yeah.
Oh, so you haven't really put the questions. Yeah, that's what I was kind of looking for.
Yeah. So the major part is the calculation because I want you to calculate the number of moles, and I want you to sit there and calculate give me a value for the amount of citric acid you have in your solution. And then the second part is the acid and base. I want you guys to kind of understand what it means, right? And so what is the difference? All the different functions.
Okay, so you're going to put that up here in just a little bit. That's all I was going to
Yep.
All right, perfect. All right, thank you, Dr. Henry.
Okay, you have a good day.
All right.
Mary, you too, have a good day. Where did you go? Everyone else, how you guys doing? Michael? How are you doing? Sienna? Angie?
I'm okay. I'm just doing the strips again.
Okay.
Dr. Henry. So quick question.
Yep.
I added the vinegar to like my Kool-Aid solution with the water and with the baking soda and with the dishwashing soap, and like a reaction occurred. So like, which kind of gas is it? Still CO2? That is the gas.
Yeah.
It's still CO2.
Yeah.
Okay. Thank you.
For this third one, it went up to like, oh, I don't know, like above the 35, like between the 35 and the 40.
Okay, so then you just record it. But that one is going to be slightly off compared to the other two. That's not too bad.
So like,
If it would have flown over, then I would have said, okay, now what's wrong now? I'd repeat it one more time. But that's not too bad.
can I say like a 38?
Okay, so then record 38.
Okay. And then after that, I kind of got lost. What were we supposed to do?
Okay, so now that you've done you got your 3 data points, right? You recorded your volume for each of those data points, right?
Yeah.
Okay. So then you're going to do a couple of calculations. One, you're going to calculate you're going to use the volume to calculate the number of moles of acetic acid in your Kool-Aid.
So that's number 19 and 20. I mean,
no, that's not number 19 and 20. 19 and 20 is only anything after that you don't have to do unless it did not work.
Oh, okay.
It worked, so you don't have to worry about that. Okay. Now you have to remember that you diluted your solution by half. So you have a half dilution.
Yeah.
Right? So if you have a half dilution, in that case, you're going to want to use this to calculate what your concentration is. Okay. You see the equation on the board?
Yeah.
Okay. So, so make note that you need to use that equation to calculate what that concentration is, and then you'll be able to go work backwards to figure out how much stuff you actually have. Okay.
Okay.
Okay. So, 20. Well, calculation for 20. So 20 you have to do only if the solution 2, and solution 3. You didn't have to. Well, I guess you use solution 2. So you're going to have to calculate the percent mass for solution 2, but you can use that equation to calculate the percent mass as well. On 21, you have to calculate the percent mass, which you already have for 1 and 2, and then you have to calculate mass volume, right, which is grams per mole times 100%. So you want to do that for solution 1 and solution 2.
Okay.
Does that make sense?
A little bit. I'm a little bit lost.
Don't worry. In class, we'll talk about those concepts. And then also in office hours, we'll be able to do that.
Okay. So if I just stop here right now and then I can finish, or because I know I have to do the pH strips as well.
Yep. And so you remember for the pH strip, you only have 3 things that you have to check the pH for. You're going to use vinegar, you're going to use baking soda, and you're going to use your Kool-Aid, right?
Yeah.
So you want to record the pH for all of those pH strips, and then also use the cabbage indicator. Okay. The way you use your cabbage indicator is you're going to remove 1 ml of your of the water, and then you're going to put that cabbage indicator into your conical tube and mix it. Okay?
This one, I empty 1 milliliter out.
Yeah, and then you're going to put 1 milliliter out, and then you're going to put that into your Kool-Aid, and then you're going to record the color, right?
So empty this and pour this, right? Sorry.
What was that?
So I empty 1 milliliter on this and then add this to it, right?
Yep.
Okay.
Let me make sure that we're talking about the same thing. Hold on. So let me see you.
Okay.
Yep, exactly. Yep. Okay. And then you're going to take 1 ml after you mix it. You're going to take 1 ml, and then you're going to add it to your Kool-Aid. Yep. And then you're going to record the color. And then you're going to take 1 ml and add it to vinegar. And you're going to record the color. And you're going to take 1 ml and add it to baking soda. And you're going to record the color.
Okay.
Okay?
Okay.
So for 21, is the mass volume and percent mass and percent mass volume, are they going to be the same thing?
That's what I want you to figure out.
Okay, I'm going to assume they are.
Okay.
Dr. Henry, but the cabbage indicator doesn't work because I just used it and it was not giving me results.
Okay, so then just write that in your lab report. Okay.
Yeah, but the yellow strips is giving me result. The yellow strip is giving me result.
Yes, that's good to know.
Yeah.
We add the whole thing of the cabbage indicator, right?
That is correct. Yes.
Did the rest of the class do part? Oh, that's part 3. Oh, we didn't do part 3 yet then, right?
Nope. You have technically. Have you already did the indicator, the cabbage indicator?
Yes.
Okay, so then you're good to go. That's part 3.
Okay, so.
Oh no, part 3 is just the calculations. That's just doing the calculations. I'll show. So you have the volume. You're going to basically use this equation to calculate the number of moles. N represents the number of moles. V represents volume. K represents a constant.
The paragraph above it, are we disregarding it? Because it's saying determine a middle concentration to use and use.
You guys already did that already.
Okay.
Yeah. So technically that part, that's what you guys were doing in the very beginning. All of the different steps there, you already did that. So you already take that into consideration.
So when we write our lab report, we're not writing anything for that little paragraph.
That's right, because you already took care of it.
Okay.
I got the same color as
Nate.
Yeah.
Okay, good.
So I would say like a black dot red.
Yes, it does look like a black clot red, yes.
And then I pour a little bit to the Kool-Aid.
When it says beaker 1, is it meaning solution 1?
Yes. Yeah.
So I poured the Kool-Aid, and it stayed like pinkish, like a reddish.
A pinkish reddish color. So did it?
The Kool-Aid was pink, and then it went to like a red.
Okay.
Is it vinegar?
Cutting out.
Is it
vinegar?
So which one? Do you see the screen? Catherine, can you hear me?
Yeah.
Okay, I said, do you see the screen? So like 1 and 2, right here?
Yeah.
Okay, so then you want to record the pH of it.
Okay.
Okay.
So like 1.
Dr. Henry, sorry.
It's okay, go ahead.
No, you can go. You were going first.
Okay, then after that's when we add the vinegar, right? Or the baking soda?
Okay, so now you get the conical tube, and then you're gonna put in that. Are you there? Did we lose her?
I'm still here. It's just my internet cutting out. Sorry.
So you want to get a fresh tube, rinse it out, and you're gonna put vinegar in it. And then you're gonna add, again, about 1 or 2 mils of your indicator, your cabbage indicator, to that. Yep.
Okay.
And
so
then
how much of the vinegar?
about 5 mils.
Okay.
You don't need much. Okay, Sienna.
So after we solve for the number of moles, it's giving us a hint for the 98% citric and 2% absorbic acid. So is that I'm referring to that we'll be needing to use like what's it called? The percent composition?
That's right. Good job.
Thanks. I've been struggling this whole lab.
Hey, but it's all coming together towards the end, right?
Sort of.
Yeah.
For the percent composition, I'd have to find the molar mass of the citric acid and the ascorbic acid. Is that what it's called?
Yeah, so right now you have a combination of both citric acid and the ascorbic acid, right? And then it did give you a hint in the, let me scroll down. Okay, it says 98% of it is citric acid, 2% of it is other, right?
Right.
So if you calculate, then if you calculated your number of moles, then 98% of it is going to be citric acid.
Oh, okay. Yeah. My brain's been like very slow these past few weeks. It's slowly dying as the semester comes.
Try getting more sleep.
You guys get sleep?
Yeah, it's kind of like because of the semester is so busy and all that, you cannot get enough sleep, and then you find out that your brain is like dying. And so, like, to me, I'm just like, just get the sleep so that when you're actually working, your brain is actually working too. So that's my philosophy.
Sorry, Dr. Henry. So I added a 5 and 1 or 2.
Also that. Yeah, 1 or 2 balls of that. Yeah.
And then I don't add the Kool-Aid to it?
Nope.
Okay.
Because now you're just comparing, because you know that vinegar is acidic, right?
Yeah.
Yep. And you're just confirming that you're not getting BS. So
Yeah, I was happy I got exactly like red. So I was like, okay, so good night, Dr. Henry, or good evening.
Night. Good night.
Yeah. Yeah.
So it stayed at a red, like a. Oops.
Okay, so then record the color
Okay. So
and then determine the pH. Here, this is out.
thank you. So I would say like a 1. And then we add the baking soda.
Okay, now pour that out, and then pour that out completely, and then put baking soda in fresh and put in some water, 5 mils of water.
Okay, so water. How much of baking soda?
A quarter of a teaspoon.
A quarter.
Yep.
So water or 1/4.
Sergio, how are you doing?
Good. I had a question towards the PowerPoint and the essay and that we turned both of them in the Chem like on the Chem project page project, right?
Yes. No, they each have their own spot to come in. PowerPoint will have a point that'll be opening up, and the page will actually, you just have the page.
Okay, so
the page itself should be under should be under your page, under your group page.
You said which one? I'm sorry.
The page.
Okay. Okay.
So you should make your page on campus.
Okay.
So are you waiting around just for that question?
What happened?
I said, were you waiting around just for that question?
Yeah, I just didn't want to like interrupt you guys' thing that's going on. So I would just add, I would go to click on pages and then add that right there, like the essay part on there, right?
Yep.
Okay.
So I added with the baking soda and water, and the alkaline it went to a blue.
Okay, so then you record that.
Okay.
Yep.
And
so
now, sorry,
you
go
also
ahead.
want to do the exact same thing with the strip. So now you can take the strips and stick it in there and see what color the strips.
Oh, my strip.
Now go ahead, Sergio.
Yeah. Do I put it for only members or anyone?
It should be for anyone.
Okay.
I need to be able to see it. If it's only for members, then I won't be able to see it, right?
Okay.
Okay.
You're right.
So I dipped the pH strip on this one.
Yep.
Okay.
And you also need to do it with vinegar. So you could just take a little bit, put a little bit in your lid.
So it's like a green.
Okay. Okay, so then record the color.
Sorry, Dr. Henry.
All right. This is the indicator for that.
So it's neutral.
It'll probably be around 8-ish, 9-ish, based upon what I saw with your colors.
Yeah. Okay. And then I was supposed to do it with the vinegar one?
Yep.
Okay.
All you have to do is just take straight vinegar, put a little bit onto your strip, and you're good to go.
Okay.
Okay, and then you do the same thing with the Kool-Aid.
Okay.
Okay. Sergio, do you have any other questions?
Yes. So for the, what is it? The PowerPoint, I would put in group presentations, right?
Yep.
Okay. And the music thing, I would put in the.
You should also put it in there as
parody.
well. Your page should have everything. Your presentation should be on your page. Your parody should be on your page, and your page, the information should also be on your page.
So basically everything has to be on there?
That is correct.
Okay. Sounds good.
Okay.
Yeah. Okay, thank you.
You're welcome. Have a good day or good night.
You too. You too.
Whatever time it is. Okay.
Okay, thank you.
Okay, you're welcome. Bye.
Yeah.
So, are you there? Do you have everything you need?
So I'm doing I did the one with the vinegar, which was I say a 1 or 2.
Okay.
A little bit orange.
Okay.
And then I'm doing the Kool-Aid one, but
yeah.
It's in the same
It's like the same color?
Yeah.
Okay, so then record what color it is.
And after that, the 3 indicator, that's it?
That's it.
Okay.
Okay, I'm gonna let you go.
Just part.
What was that?
Okay, the last part, calculations, right?
Yep, that's right.
Okay.
Okay.
Thank you so much, Dr. Harris.
You're welcome. Have a good day.